and how the data warehouse will work. All those things I'm going to explain. So here is the architecture, how the data warehousing and why we need data warehousing. All those things I'm going to explain. So basically, if you take any kind of organization level, so data warehousing is one of the crucial part for any client and any client specific data. Okay, because why I'm saying it's a crucial, because nowadays there are so many transactions. If you take digital transaction, there are offline transactions. These so nowadays everyone doing the digital transactions. If you take phone pay, Google Pay and Paytm, there are various digital transaction apps are available in market, and people's just they can go and they can purchase whatever they want. So earlier, what we are doing in before these apps came in, so we used to go to that particular store and we are paying with the credit card or debit card, or you are paying with your money, right? So that time there are not that much crowd how nowadays the digital transactions are happening. Okay, so that's why now the data is also a now companies are getting large volume of data transactions. If you take Amazon, Flipkart, and Myntra, so there are various kind of retailer applications which they are running their stores, and their transactions also growing on day-to-day basis. Okay, so while increasing this data, so managing the data is also one of the crucial part, right? So these many data we are getting transaction, and also we need to maintain a proper capacity of data, and we need to maintain proper layers of data. So that is one of the important thing which is very crucial for any client. Okay, so maintaining their data and their database. Okay, so that's where the data warehouse process came in. And what we earlier also we have the data warehousing, but nowadays it's more we are using data warehousing process because these transactions are increasing and the data is grown more on day-to-day basis, and their business also growing. So all these perspectives, nowadays we are designing this data warehousing process. Okay, so we used to get our source data, and we are going to store into the staging layer, and thereafter in data warehouse process we are going to make those data like all the data manipulations, everything done in the data warehousing. And whatever the transaction like total sales, average sales, and sum of sales, all those things will be calculated under the data marts. And finally, we are representing into the Power BI dashboard to show the reports. Okay, so this is how the quick overview of how the data warehousing architecture will work. Okay, so still here this is even in my day one class I have explained. So we used to have some raw files which we will get from source, and we are storing as it is into the staging layer without any manipulations. And then we are doing all our transformations and other process in the warehouse, and then finally we do the aggregations in the data mart layer level. Okay, and then finally we will represent like a Power BI, SSRS, Tableau. So based on the clients, so we are representing into the reporting level. Okay, so here as part of data warehousing process, we need to understand two criterias. Might be most of the team know since they're working in real time. So we have two different kind of data warehousing models. One is the star and snowflake. Okay, so what is star and what is snowflake? Okay, so before going into this, so in a data warehousing process, so basically it depends on dimensions and facts. Okay, so if you take the terminology of data warehousing, so it's a dimension and facts. So these two are the common terminologies which you are going to see in our data warehousing process. So you may get the question like how these dimensions and facts. So these dimensions and facts, basically we have a wide variety of business apps. So based on your business and based on your applications, so we are going to design the dimensions and facts. Okay, so dimension is nothing but which stores the your complete textual with numerical data. Okay, so it's like example, you have a customer, so customer having a customer id, customer name, and location, and price. There are various aspects in the dimensions. And if you take location and product and orders, so there are various kind of files which stores their textual and as well as a numerical, both will be there here in the dimension level. Okay, so whereas in fact tables you will completely take the data from all the dimensions and you will generate your fact tables. Okay, so this fact table will get the data from the dimension table and it will generate all the numerical information like percentage of sales and average of sales and total sales. So all this numerical storage will get stored into the fact tables. Okay, so now this data warehousing process is divided into two types. Okay, so one is the star model and another one is the snowflake model. So these are the two model which in our data warehousing process repeatedly we will use for our day-to-day processing. Strategies, right? Like star schema and snowflake. So basically the star schema level, right? So we have a limited dimensions and limited fact tables. Again, it depends on your application, how big it is. Okay. So based on that, we will design our star and snowflake. Okay. So we have our fact tables and these fact tables are designed with your dimension tables. Okay, so these dimensions are allocated like this way and in a star shape, and we are going to give the each relationship between the dimension and fact tables. Okay, so this is how the star going to represent. Okay, so you may have multiple dimensions or multiple facts, but based on your application, so we used to divide those files and we are going to design while we are proceeding with the solutioning part. Okay, so why I'm saying solutioning part once we develop, because whenever we are doing starting any development, we need to know, especially for the ETL process, we need to know what are the input files. You need to understand the business and what are their data, and then you will design this data model as part of architect level. Okay, so once you have done this designing, you will go for the solutioning part, and then you will perform all your operations. Okay, so this is a snowflake model. Okay, so you can take all this snowflake and not snowflake, sorry, it's a star model. Okay, so in the star model we have a fact and we have a dimension. Each dimension have a related keys. Okay, example, in this table I have a example, this is a customer id, so I used to have a customer id, and here is also we are going to keep the customer id, and we will join with the similar way, like if you have a order id, so order id is the key, and if you have a location id, so location id is the key, and example, it's a date dimension, so it's a date key. Okay, so like this way each table have relationship, and we are going to join with all these tables with the fact tables. Okay, customer, order, and date. Okay, location, everything will be uh, mapped in the star model. Okay, so similar way, so if you take the snowflake model, so similar way, so snowflake model have the sub dimensions. Okay, so we have a multiple facts and multiple sub dimensions and sub facts. Okay, So example, this is a fact, main fact, and I'm going to divide with the multiple facts. So this is the sub fact again. Okay. And similar way, I have a more number of dimensions. Okay. And I have mentioned, right? So it's depends on your application again, the volume of your data and your data volume. So based on that, you are going to design your data model again here. So similar way, we are going to align with the relationship with each dimensions and facts like this way. So all these facts and dimension get connected to the fact tables. Okay. So and here again, the dimension have the sub dimensions. So here I'm going example, this is a customer dimensions. Okay. So in this customer, I have one more customer called sub customers. Okay. So like this way, we used to have some sub dimensions which are connected with the each dimensions. Okay. So again, if you have a more number of dimensions and you need to create multiple fact, it won't be easy to design for the snowflake models. You need to, if you have a bigger requirement, so you need to make sure that again, if you create more dimensions also, it will be difficult for you because to maintaining all this data and processing this data, it is a challenging part, right? So earlier what happened, so when I am working, so there is a analysis service, SQL Server analysis service. In that one, what happened when we are designing, so we used to use 50 dimensions and some 10 fact tables. So like that way we designed in our past, but that is very very difficult. So when you are processing your entire data in the cube level, so those will take give the performance issues, and there are a lot of challenges which we are facing. So that's why nowadays what we are doing in synapse or any other tool, so we are dividing our data. So we are not just simply keeping all the 50 dimensions or 40 dimensions at a time. So we are just dividing into the multiple cubes, and then we are processing the data to get more accurate, because these cubes run hours on hours, and it will take huge amount of time. Even if you process any quarterly data or monthly data, we are facing so many challenges that time. So that's why dividing all these dimensions and based on the requirements, so we are making our data as a uh, optimized way. Okay. So that instead of running a cube in like 10 hours or 11 hours, so we are just cutting down to the multiple dimensions and facts, so that easily we can process this data based on our requirements. Okay. So this is how mainly data warehouse will work. So data warehousing having dimensions and facts concept, and it is a star and snowflake. Okay. So both the models are available in the data warehousing process, and this is again depending on the SCD types. Okay. So most of them, since we are all working in real time, we may know the SCDs, how SCD is going to work. I may not going to explain more. I'll just give some brief details and then I'll go ahead. Okay. So SCD is a slowly changing dimension, so which is again doing a crucial part in data warehousing tool. If you are doing any data warehousing process, you have SCDs will play a crucial part. We have a type 1, type 2. So we have a SCD type 1 and type 2 and type 3. So we have a three types. Okay. So these three types we will design based on our requirements. Okay. So this is a type 1 and this is a SCD type 2 and this is a SCD type 3. Okay. So if you take any our real time whole process is depends on this SCD process. SCD is very very important point of concept for any data warehousing objective. Okay. So SCD type 1 is like so if you wanted to have example, you have a column called a location, or if you take any product, anything. Okay, so any changes happen to your historic, so it mainly deals with the current trends and historic trends. Remember this point. So current and historic SCDs will deal with these two criterias. Okay, okay, so that we call it as OLTP. So as part of our technical terminology, it is a OLTP and OLAP process. Okay, so OLTP is online analytical process, transaction process, and OLAP is an online analytical process, and this is the transaction process. These two are the process. All your data will depends upon these two transactions. So your data warehousing process depends on these two. Okay, so it compares with your history data with your current data, and it will make a decision whether you need to perform a insert, update, delete. So what are all the operations you will do? So you will perform the insert and update. So most of the time we will do the insert and we'll do the update. So these two things are happening. Suppose if we did not done these two, what will happen? You may get a question. So I don't wanted to do this process. What will happen to your DB? Your database will be grown up, and your database having the all the transactions. Even though your data having a modified data, so all the data gets stored into your DB, and your DB was grown like anything. Okay, so that is the again the challenging part. So always we will follow the SCD types to follow the historic transactional maintenance. Okay, so now current OLAP and historic, right? Suppose example, let's take an Excel file to represent these values. So I'll quickly represent this. Okay, so example, you have a product ID and product name and location. Okay, so your product name is one and product name is a laptop, and location is equal to so USA example, and this is a OLTP current transaction. Okay, and I have a history transaction also. In this history table, similar way I have this data, so let me copy it. Okay, and second one, and I have a hard disk, and it is belongs to UK, and I'm going to add company, and it is a HP, and this one is belongs to Dell company. Okay, so let me copy this one as well. Okay, so now I have so this is a example. So I'll add another record, that is a third record with desktop. Okay, so now desktop, and this is India, and it is a Lenovo. Okay, so this is one of the current transaction table. Okay, and this is my historic transaction table. So I'm going to add the company names as well accordingly. Okay, so what happens is, I'll just remove this. Okay, so here we have this is a current transaction table. Current transaction table having three records are there. Okay, 1, 2, and 3. And if you take here, so I'll add this laptop as a India. So we are no more selling this HP laptops in USA, and it is now they are started selling their business in India. Okay, so if you take historic table, right, so it will compare with this data in SCD type 1. What this will do is, this will override the data into the database. So this won't maintain any history. Remember this, it will directly go and compare with this product ID, and this will just override the data. Okay, and the third record as it is, it will insert into the database. Since this is a new record, so that's why it is just going to insert this record. Whatever the existing is record is there, that is updated with the current transaction data. Okay. If you see here, I wanted some 1 month or after 1 month. So my manager is asked, so laptop earlier, which country we are selling this particular laptop? So I don't have any history. If I come and check in the database, select star from this product table, so I cannot found any history about the laptop. So that is the one of the biggest drawback in SCD type 1. SCD type 1 is you don't maintain any history, and this will simply overwrite your data. So at what situation you will use this is, so if you don't want any history, you can simply use SCD type 1 to make this data. If you want history, then don't go with this SCD type 1. Okay. So this is a SCD type 1, and I'm going to represent the SCD type 2. Okay. So in SCD type 2, so let's take the similar table and we'll just represent over here. I'm going to add this too. So this is currently in USA, right? So example here, now the current location is USA. Okay, so now in my history table, it's a India. Okay, so what will happen in our SCD type 2 process is, so there is a one more record going to come. Okay, so one more record going to come. In this one more record, so this will be the fourth record, and here we are going to maintain dates as well. Dates with flag, start date, and we have a end date. So end date, and we'll maintain the flags, because if you did not maintain any flag, you don't know whether it's a active record or inactive record. So that is where we are adding the flag concept and the dates as well. So till what date these operations are happening in India. So India example, it is operated till yesterday, 08, 27 and 2024. This is operated from, no, start date is like we will give some 2021. So from 2021, from India, HP is selling their laptops, and so when they ended, so they ended on this date. Okay, let me add this date. So they stopped this product on 2024. Okay, so now we have a end date. So okay, so since end date is there and the flag will be 0, flag will be 0. Why I'm making, because we are no more selling in India, that's why I'm making it as inactive. And now fourth one is there, right? So this is the current one, so you need to update with, so it will be update with USA, it only having the start date. Remember this point, whatever the new transactions are happening, so that is having only the start date, and your end date will be null, because this is started now and we don't have any end date here, because we are still selling in USA these laptops, and your flag will be 1. Okay, and so similar way, so if you have a new record, it will get inserted, and if you have a existing one, it will get updated into the database. So that is how SCD type 2. And SCD type 3, you have a current and previous. So let me take here, and it will just update with this data. So and we will just add current and previous. Okay, so I'll just update over here. So if earlier it is selling with in USA, so we have a one more column called current. Okay, so it maintains that. So in your today's file, it's a UK example. So this will add as a UK date, and it is in the previous location. So this will maintain the previous. So current and previous, these two versions will be available, and it maintains the current and previous two versions in SCD type 3. Okay. So this is how it works in SCDs. SCD type 1, type 2, type 3. So these are the types your data warehousing will be process your data. So this is how all slide I have represented, how the dimensions, and so this is the model of star schema and snowflake. Okay, so all those things I have represented. So this is the project model where I have designed for our going forward upcoming project. Okay, I took the retail data set, so I'm going to show each and everything while I'm doing the project. Okay, so I have taken all the orders and items, payments, customers. So it's basically retail domain project. So no need to worry. I will just explain more on our project. Okay, so this is for to understand your process. This is the model which I'm going to follow to design our project model. Okay, so hope this is clear till what I have explained till this all the concepts are clear, right? As part of data warehousing. Might be so you everyone know, right? This SCD process or um, everyone know, right? Okay, yeah.
Very good.
Okay, yeah, yeah. Thank you. So now let's quickly move on to our Synapse workspace. Okay. So here, so in our earlier session, so I have explained the pools, right? So this is a serverless pool we have designed in our earlier process. Okay. So these are all the process we have designed, and it comes with the inbuilt process. So now let me upload some sample files. So go to here, and to show you the examples, I'm going to add the files. Okay, I have already added one file. Okay, we'll use this, or otherwise I will I'll upload one more time. Okay, so what I'm doing is, so I have all the input feed files which I have. Okay, so these are all the input feed files which I'm going to use for my projects and the requirements. Okay, so example, I have a customer data set, right? So initially, so I'm going to upload. How we are going to upload? Click on upload and browse option. So once you click on the browse option, we have a customer data set. Click on this and upload it. Okay. So once you upload it, so it will get uploaded into the ADLS storage account. Okay. So now simply like let me right click. Okay. So after clicking right click, you can do these options. You see, new select SQL script. Okay. So in this SQL script, so it will auto generate the scripts over here. Okay. So now this is the script which is generated, and open row set is there, and the format is there, and the versions are there. Okay. So basically this open row set concept usually use it to read the files which are available in any storage, like available in our data storage, right? Like ADLS Gen 2 or Blob. It is designed to read the files in the format of table. So the open row set is especially designed for to read any